Hello students, today's agenda is to return test. You're going to be turning in packets for Unit 10 and we'll learn about variable coordinates. You will be able to do 11.1. Students will be able to find variable coordinates. And so we're going to start with a warm-up to relate it to what we will be seeing. And so if you can pause the video and try it on your own. So before we start, I want to kind of go over things that you might already know, and it's that this is the coordinate plane. This is a coordinate. This is the x coordinate and the y coordinate, and it's always in alphabetical order. And so the coordinate plane is divided by the y-axis and the x-axis into 4 quadrants. So this is the y-axis, this is the x-axis, and this is always positive and this is always negative. So positive y, negative x, positive x. And also this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. And this is written in Roman numerals. So you start here and then you go around like this, like a letter C. That's the order. Okay, so now to graph, you always start with X all the time and then Y. And you put the point only until you go to Y, not on X. So you always start on this point, which is called the origin. And the coordinate is 0, 0. Right here is 0, 0. So that's where you're going to start all the time. And it says plot 4, 5. So 4 on X, 1, 2, 3, 4, 5 on Y. Notice that I didn't put my point in there. I'm going to trouble now 1, 2, 3, 4, 5. So the point is right here. So that's the first point, which is 4, 5. When I count, I start counting here. 1, 2, 3, 4. So it's after I make the jump. And then 1, 2, 3, 4, 5. Okay, the next one again, always X first, but this time is negative 4. So negative 1, negative 2, negative 3, negative 4, positive 5, 1, 2, 3, 4, 5. It's right there. The next one is negative 4 on X, negative 5 on Y. So it's going to be negative 1, negative 2, negative 3, negative 4. And then negative 1, negative 2, negative 3, negative 4, negative 5. The point is right there. And finally, positive 4 for X, negative 5 for Y. So it's 1, 2, 3, 4. 1, 2, 3, 4, 5. Since it's negative, we go down. Okay. And after that, in some tests, they will ask you what shape does the following points form. And so what you can do is graph the points, connect the points, and see what kind of shape you're given. Okay, so in here we can see that it has created a rectangle. Okay, the next one is going to be 0, 5. So 0 on X, that means that I don't move on X, and then Y on 5 on Y. Y is up or down, so I don't move on X, but then I go up on Y. So 5 right there. Then in here, I move on X 5 spaces, 1, 2, 3, 4, 5, but then I don't move on Y because it says 0, so that's the second point. Then it's 0, negative 5, 0, I don't move on X, either left or right because it's 0, and then negative 5 on Y it's gonna go down. So 1, 2, 3, 4, 5, it's right there. And the last one, x -5, y is 0, so -1, -2, -3, -4, -5, and then 0 for y, so I don't move, it's right there. And I'm ready to connect my points. And what kind of shape is it? Well, you can see that it's a rhombus or diamond, okay? So I want you to see the relationship that for these 2 points that are apart from each other, they're away from each other exactly the same amount of points. Where are they? So -5, it's right here, -5, 0, and then +5, 0, it's these 2 points. Notice how they have 0, 0, they have -5, 5, but one is positive, one is negative, because one is this way and the other one is that way. And for the other one, in y, this is +5, and then this is -5. So the same coordinate, but one is +5, the other one is -5, because they have the same distance. It's just in different directions. Okay? Okay, so suppose that we have a figure and we need to find coordinates, but we don't have the units, we don't have the squares. However, we can see that A is at the same distance from X, and we can see that D and B is at the same distance than A and C. Okay, so let's say that these are our this is our coordinate plane. And what do we know about point C? What do we know about that point? Well, every time we have a point right where the 2 axes meet, that's going to be always 0, 0. Okay? 0, 0. Let me see if I can fix. There you go. Okay, so sorry about that. We'll see how it goes. Not liking it. There you go. Okay, so in here, we know that this went up, but we didn't go left or right. Left or right is on X. So that means that if it doesn't go left or right, that's X is 0. Okay? And your Y, it's going to go up some distance that we don't know. And usually the distance for distances they're using A, B, and C in lowercase. Okay, so we're going to put 0A as being the distance for that. So that represents some distance that we don't know. Okay. Point D, it goes some distance, is not the same distance, right? So we cannot use letter A, but on X, it goes some distance, but we don't know what it is. So we're just gonna use the following letter, which is B. And it doesn't go up or down for Y, so that's 0 right there. So the coordinate for this point is B0. B representing some distance that we don't know. And in here is 0 because you don't go left or right. A, which A represents this distance right here. Finally, to get to this point, remember that we had to go X first and then Y. So what's the distance from here to here? Well, that's letter B. We don't know what the distance is, but I know that it's represented from here to here is represented by B. And then we go up on Y to get to this point. Again, this is the same distance that we used here, so that's A. Okay? So A represents from here to here. That's Y. So that's why in y, since it's the same distance, we put a in here. And b represents the distance from here to here. So that's why we put b in here for both. Okay, because it goes the same distance. Both go the same distance on x, but then for this point, we also go the same distance as this one, which is a. Okay, let's try another example. And so find the coordinates of B, C, and D. They're giving us already point A, which is negative a, b. Notice that now the coordinate plane is right here. So this is my origin. This is where the two axes meet, the y-axis and the x-axis. So to get to this point, we know that from 0 to here, it's going to be a, right? Because that's how much we traveled. The distance is a, but since it's on the left, it's negative a. So that means that point C is going to be, for x, I move this much, which is negative a. And then I don't move up or down, so that's 0. Okay, if you still don't get it, just stick with me and hopefully you'll get it. Okay, so a represents some distance that we don't know. It's to the left, so it's going to be negative. For point D, it also moves to the right, but it doesn't move up or down. So we're going to move on x, but not on y. So y is going to be 0. Notice that this distance is the same as this one. So it's going to be letter A also. But if this is negative because it's going to the left, this is going to go to the right. So that's going to be positive A. Okay. And that's it for that one. For B, we go that same distance on x, positive A. And we also go that distance on y. We already know that that distance on y was labeled with b. So that means that that's b, right? This is the distance b. And therefore, this is going to be b as well, because they have the same height. Okay? So hopefully you're kind of getting it. I know that it seems a little bit confusing because we're using variables instead of numbers. But let's see if it gets better and better. Okay, so now find this one. Notice how now the coordinate plane is meeting right here. So this point is 0, 0. And first we travel on x and then on y. That means that this is going to be a, the value is a, but since it's going to the left, it's negative a, and then it travels up, so that's labeled as b. So from here, we're going to travel on x, positive a, because it's going to the right, but the same units, same distance. And then it goes up, so that's my y, which is b. Okay, so this is x, this is y, so x and y. So basically, same distance traveled for x, but this is negative, this is positive. Same distance traveled for y, both positive because both go up. For this one is left, so it's negative a, right? It's the same distance. And then down, but the same distance. So it's b. However, it's going to be negative because it's going down. And for D, x is going to the front, same distance as this one, so it's a. And my y, you go down. So, but the same distance, so it's going to be B, but going down is negative. Okay, so that's how you label these three other points. Again, A and B represent distance, and if they are the same distance, you keep it with the same variable. It's just if it goes to the left or down, it's negative. If it goes to the right or up, it's positive. Okay, let's do one that it's a little bit more interesting. So it says find the coordinate of B and C. Again, this is my y-axis and my x-axis, so that makes it easy for B, right? That point is where? It's at the origin, so it's 0, 0. What about point C? Well, that distance is not shown anywhere else where I can just copy my x so that I know how much I travel. I know that it doesn't go up or down, so I know that for my y, it's going to be 0, right? Because it doesn't go up or down. However, I have this point, which is right here. So basically, to get to this point, I had to go kind of like that at this point, and then I had to go up. So that means that this is from here to here is the distance A, and then from here to here is distance B. But what about from here to here? How does that compare to any of those 2 points? Well, this is A and another A. So basically we can say that from here to here, whoops, from here to here, it's gonna be 2A. Why? Because I'm traveling A 1 time, 2 times. Okay? So they gave me this information, and that's how I use it in reference. I have 2 of those, so it's gonna be 2A. Okay. It's getting a little bit more complex. So it says find the coordinate of B and D. So for B, again, easy, right? Easy, because it's at the origin, so it's 0, 0. We know that to get here, this is A, and then this much is B. And then from here to here, we know that this distance is, from here to here, is C. Okay, so this is C. But let me, I don't know if you recall that this is a parallelogram. Parallelograms go like this and they tilt so that this distance is the same as this one right here. So that's going to help me find my point D, the coordinates for point D. Why? Again, because this, see how you have this A, B? So this is the same as A and then B. Okay, so I know easily that for Y, it goes up the same distance, so it's gonna be B. However, what's gonna be for X? Well, it's this much and then this much also I had to travel. So how much is from here to here? That's C. But then I travel a little bit more so that I can get over here. Otherwise, I'm going to end up in here if I don't travel that much on X. Okay? So it's going to be C plus, remember this is the same? So plus A, because I added this extra in here. Okay? So my X coordinate is going to be the measurement of C plus the measurement of A together. And the distance for the Y is just from 0 to here. So that's just B. Okay? Let's do one more. And this one has different letters as well. So what is B and D? Well, we can compare D to A and B to C because this is the same distance as this one, right? So let's start with B here. Okay, on X, this was C, right? Because that's X and Y. So X is C. So going this direction, it will be the same distance, but now negative because it's going to the left. And you don't go up or down, so that's 0. For D, notice how you had to go negative A, that goes out here, and then B to go there. So now to get here, I'm also traveling this much to this point, and then this much to get right to where I need to be. So how does this compare? Well, it's the same distance as this, but it's positive because it's going to the right. And then this is the same distance and both are going up, so it's going to be positive as well. Okay, so this hopefully is helpful so that you can complete 11.1, and I hope you have fun.